So we're going to be looking at the Chapter 11 quiz guide on transformations for 7th grade. And let's go ahead and get started. So there's basically 4 different types of transformations we've done: rotations, reflections, translations, and dilations. And so the first one here says, given these 3 points, translate 2 right and 1 down. Now, in case you don't remember, the way we do translations is by adding and subtracting numbers to the x and y coordinates. And so you can use this kind of handy little cheat grid here to memorize what to do where. So if you're going right, that's adding to the x. If you're going left, that's subtracting to the x. If you're going up, that's adding to the y, adding to the y. And if you're going down, that's subtracting from the y. So if we have our points here, we'll list them out here. We'll call them A, 1, 3, B, 2, 5, and C, 3, -2. We want to go 2 right and 1 down. That means we're going to add to the x and subtract to the y. Again, down being subtract and right being add. So add 2 to all the x's and subtract 1 from all the y's. And so my new point, A prime, and again, we just say prime as like the new A point. Prime just means like new point. 1 plus 2 is 3. 3 minus 1 is 2. B prime. 2 plus 2 is 4. 5 minus 1 is 4. And C prime. 3 plus 2 is 5. -2 minus 1 is -3. And those are our 3 new points: A prime, B prime, C prime. So translations just deal with adding and subtracting the right number to the right coordinate. Probably one of the easier transformations. The next one is rotating counterclockwise. So rotations by 90 degrees involve multiplying by -1 and then swapping the coordinates with each other. So in this case, I want to rotate 90 degrees counterclockwise. So counterclockwise, CCW, means you're going to take your x and y number. You're going to take your x and y point. And if you're going to go counterclockwise, you're going to multiply the y number by -1, and then you're going to swap the positions. So you're going to end up with -y comma x, or opposite y comma x. So if I list out the points again here, 4, 2 is 5, 7. C is -4, 3. So what it means to do is take your y number and multiply by -1, and then swap the positions. So my new point's -2, -4 for A prime. Same for B. Multiply your y by -1, so -7, and then swap. So -7, 5. And then same thing for this one. Multiply your y by -1, -3, and then swap, and you get -4, -3. Whoops, sorry. I actually forgot to swap my points. Let me actually do that now. It'd be -3, -4. So clockwise would be doing the same exact thing, except you multiply your x by -1 first and then swap rather than your y. For number 3, we have reflections, and reflections are basically easier rotations. So reflection, all you do is you take a coordinate and you multiply it by -1. If you're reflecting over the x, that means take your y and multiply by -1. And that's all you do. So, for example, A is 0, 3. Take my y and times it by -1, and you get 0, -3. B is -7, 0. Times by -1, and you get still -7, 0. That one doesn't change, which they won't always. And C is 2, 2. Times by -1, and you get 2, -2. So it's just a matter of knowing the rule for the transformation and applying the rule correctly. There's really no other trick to it other than to do some rule memorization on your own. The next one is the same thing, just dealing with the graph. So I'm going to label these real quick: A, B, C, just so I have something to refer to. So I want to rotate this 90 degrees clockwise. So when you want to rotate a figure, all you have to do is look at the vertices, look at the corners. That's what vertices are, corners. If you can do the transformation on the corners correctly, then the whole shape will move like you want it. So we're going to focus on the corners A, B, and C. So A, which is 2, 3. B, which is 2, -1, and C, which is -1, -1. 90 degrees clockwise. So remember, clockwise means take your x number and multiply it by -1, and then swap your points. And same thing for B. Take your x number and multiply it by -1, and then swap your points. And once again, take your x number, multiply it by -1, and then swap your points. So all I'm doing here is times it by -1 for the x, and then swapping the points once I've done that. So it's basically the reverse of a counterclockwise. You multiply the x by -1 rather than the y. Now it says to graph the shape, so let's go ahead and graph the shape. 3, -2, that's going to be down here. That is A prime. -1, -2, that's going to be right here. That is B prime. And C is -1, +1. So that's up here, C prime. So my new, probably should do something other than blue. My new triangle would be something like that. Okay. So my next one here is reflecting over the y-axis. So I want to reflect this shape over the y-axis, and just like the x reflection, all you have to do is multiply something by -1. In this case, if you want to reflect over the y, you multiply the x by -1. So it's kind of counterintuitive. The axes you reflect over, it's the opposite coordinate that you reverse. So let's just list my points out here. So R is -4, +3. U is -5, -5. And then T is 3, -4. And then lastly, S is 4, -4, sorry. Nope, +4, my bad. 4, 5. Let me write that better there. S is 4, 5. So now I have my points listed. Again, this right here says x times -1. So this would be 4, 3. This would be 5, -5. This would be 3, -4. Or sorry, -3, -4. And this would be -4, +5. And then you go ahead and graph the points. So 4, 3, that'd be right there. 5, -5, that'd be right here. -3, -4, that'd be right here. And -4, +5, that'd be right here. And so then I'd have my parallelogram looking like that. What you expect for a reflection over the y. So it kind of looks like it's been flipped over the y-axis there. So every point has been kind of switched sides. But reflections, like I said, are basically easier rotations because all you have to do is multiply by -1 for one of the coordinates. You don't have to worry about swapping them. With rotations, it's multiplied by -1 and swapped. They kind of share a link. The next one's about similarity. So similarity and dilations kind of go hand in hand because dilations is just basically how you get a similar figure. You either dilate it up or you dilate it down, for lack of a better word. So the way you check for similarity, so this says determine if the figures are similar or not and explain why or why not. Well, the explanation is basically your work. So the way you figure out if something's similar or not is if you take corresponding pieces and you make them into fractions or decimals. All those fractions or decimals should be the same. If just one of them is different, then the figures aren't similar. So for example, we have the left side here and the left side here. So let's put those as a fraction. 16 over 12. Left side of the big one over left side of the small one. We'll do the right side over the right side, so 8 over 6. And we'll do the bottom over the bottom, so 20 over 15. And I want to see if these fractions are the same. Well, we can reduce them, so I can divide both of these by 4, and that will get me 4/3. I can divide both of these by 2, divide both those by 2, and that will give me 4/3. So far so good. And I can divide both of these by 5, and that also gives me 4/3. So in this case, since every fraction reduced is the same, these are similar. So yes, they are similar. Because the fractions end up being the same when you reduce them. The only trick here is you have to make sure they're corresponding pieces. So you have to make sure you're creating the right fractions. So left over left, right over right, bottom over bottom, that sort of thing. You could also make them into decimals. So you could do 16 divided by 12, 8 divided by 6, and 20 divided by 15, and you get the same decimal every time. And that's how you know that they're similar, because you're getting that same decimal every time. Now, the last one basically has you use this property to solve for a missing piece. So it's not asking you, are they similar? It's saying they are similar. I want you to find the missing spot. So we have shape A and shape B. So we'll call it this shape A. So here's shape A, and then here's shape B. We'll do it a little bit bigger. So there's shape B. It says this one has a perimeter of 20, and shape B has a perimeter of 15. Okay, so far so good. I probably should have drawn shape B a little shorter. Let's do that actually. That way it doesn't look confusing. So shape B having the smaller perimeter is probably the smaller piece. So I'll do, that's B. So it says if the length of shape A is 4, so we'll call this the length of shape A is 4, how long is shape B? Assuming that's similar and we want to keep the similarity. Well, we're just going to go ahead and plug in our fractions. So remember, being similar means that the fractions, even with the perimeters, should be the same. So for example, if I take 20 over 15, that fraction, when you reduce it, should be the same as if I take 4 over whatever this is. Well, if I don't know what it is, I just put an X there, right? So you have perimeter over perimeter is the same as length over length, and that is true if the shapes are similar. And so what we're going to do is cross multiply. 20 times x is 20x. 4 times 15 is going to give me 60. Divide everything by 20, and you get 3 is equal to x, and that is the length of shape B, 3. So in this case here, we are using the fact that similar figures have this constant fraction that they can use to help figure out a missing piece of the puzzle, so to speak. So that's it for the transformations guide. Again, it's a lot of rule memorization for the transformations, so know how to rotate, how to reflect, how to translate, and how to dilate. And then there's some procedures that you need to know for similar figures, although that's been covered before as well, so that should be a little bit easier to grasp. But it's a lot of formula and rule memorization, so make sure you practice your formulas and rules, make sure you get them in your head, and you should be fine. Hope you enjoyed the video. Have a good day.